Welcome, everybody. Hopefully you've enjoyed Data Toboggan Cool Runnings 2022 edition a lot. Hopefully it's been an excellent day so far. We're going to continue that by talking about security. And this is a big topic, as you would expect, given that Azure Synapse Analytics is pretty big. So we will go through pretty quickly. That said, if you have questions, please do feel free to put them into chat. I will have chat right in front of me right here the whole time. So we'll see. I'll be able to answer any questions as they come in. So with that, welcome to Locking Down Azure Synapse Analytics. My name is Kevin Feasal. I'm a Microsoft Data Platform MVP out of Durham, North Carolina, which is the other Durham, not the one that's a little bit north. I run a predictive analytics team, and I have a blog called Curated SQL. The idea behind Curated SQL is I try to find and link to 5 to 10 posts per day on topics all across the data platform space. So that's curatedsql.com. What I'm going to do here is provide a high-level overview of Synapse security. And I have to emphasize high level. I have to do a little hand gesture thing, because to do this in its full depth would be literally a full day exercise. I know, because I've done it. That said, we will briefly cover network security, workspace security. We'll talk about connecting to outside resources. We'll secure the 3 major pools. Because Data Explorer pools are still in preview, I'm not going to focus on that for security. My assumption is that in preview, security details can change. So I don't want to provide any advice on it right now. And a little bit of additional tooling if we have time. We're at a conference on Azure Synapse Analytics. What I'm going to do for time is assume that you already know what Azure Synapse Analytics is. And instead of walking through what each of the pools does, I will note that you can grab the slides later on, and we'll get an idea of a little bit of my brief pool advice. Also detailing pipelines and link. So Synapse pipelines like Azure Data Factory, Synapse Link connecting data sources, Cosmos DB, the first one, but also Dataverse and SQL Server 2022 links exist. But you'll probably get that information in other sessions as well. So let's talk about security. Now, before you go out and create a Synapse workspace, there's a little bit to talk about, a little bit to think about. And one of those topics is regulatory compliance. So there are a variety of regulatory regimes that we'll have to think about to consider. You may want to review the Microsoft compliance offerings. So this is a website that Microsoft has put together about what are my industry requirements. So for example, if you have NBB and FSMA, which is National Bank of Belgium and Financial Services and Markets Authority. I learned something new today because I just clicked on an arbitrary one, and it gives an idea of what Microsoft services are in scope, what Microsoft services can apply to this regulatory authority, as well as details on how you can make sure that your offerings can pass whatever regulatory compliance regimes you're following. So one of the key points to make in that area is that regulation is a two-way street. Microsoft provides part of the answer, but you have to provide the rest of the answer. So typically, Microsoft is going to control the hardware. You'll control the access to the hardware. Microsoft can offer encryption, but you can bring your own as well. You control how things get encrypted. Microsoft controls the network, but you're controlling the data. So in other words, just because you're running something on Azure does not mean it's necessarily PCI compliant. It's HIPAA compliant. It's FISMA compliant. You have to do work on top of what Microsoft provides. What they provide is a guarantee that, hey, if you're doing the right work, that they've got their part covered. Now, one of the key principles of a lot of regulatory regimes is the idea of following certain data collection principles. I would summarize this as encrypt the data whenever it's at rest, whenever it's moving, just encrypt the data in general. Ensure that any sensitive data you have is actually necessary. If you're collecting sensitive information, but it's not required, it's better not to have that information. You can't lose what you don't have. And tying into that, if there is data which is obsolete, especially if it's sensitive data, finding ways to destroy that data is a solid choice. Now, you will, of course, need sensitive data in organizations to some extent. And thus, we grant access as it's needed to the people who need it, but not broadly to everybody in the world. When it comes to business continuity, high availability, disaster recovery, Microsoft is generally responsible for most of the high availability in Synapse, meaning if you create a dedicated SQL pool, they are already distributed, assuming that you have more than 500 DWUs, at least 1,000 DWUs, I should say. And they're highly available by default. So if a service goes down, Microsoft is responsible for getting that service back up. And when it comes to the serverless SQL pool, this is also highly available, though I have noticed the service fail quite a few times in the past. So highly available is, dependent on how you define highly. Spark pools, I would consider that more of a user controllable high availability in the sense that your pool has failed. Spin up a new pool. Now, again, I've also experienced, especially in Western Europe, that there have been times when it's been difficult to spin up a new Spark pool, that they've hit their limit of resources. So you can run into cases where high availability isn't as high as you'd hoped. For disaster recovery, this is more of a joint effort. Dedicated SQL pools will take automated snapshots. Their recovery point objective is 8 hours, meaning you can lose up to 8 hours of data. The retention is 7 days. They're going to hold on to these backups or these snapshots for 7 days. So you can go back to a prior snapshot if for some reason some disaster has happened and you need to restore to a new Synapse workspace. You may also take manual snapshots. I'm going to take a snapshot of this dedicated SQL pool. This is especially important if you don't run the dedicated SQL pool that often. If you maybe turn it on for a couple hours a day to do some ETL processing and then turn it back off to save money, that may not be long enough for the automated snapshot engine to kick in and take a snapshot. So in that case, you may want to take a snapshot yourself so that you can have something in case of disaster. The pools themselves are automatically backed up to another region every 24 hours. Again, this assumes that things are on. If you only turn the pool on every once in a while, that may not happen as effectively. Other pools, so your serverless pool and your Spark pools, they will store data in the data lake, which means you're dealing with Azure Data Lake storage on top of Azure Blob Storage. I would recommend for that geo-redundant storage because now you're disaster recoverable. If there's an entire region failure, you can use an alternative region. So I have DR capabilities tied in there. It doesn't need to be a read available geo-redundant storage. It just needs to be geo-redundant, I would say. So we've talked about a few of the things that you want to think about before setting up a workspace. Now, let's talk about the setup itself. There are a couple of options that you're going to want to consider before you go and click new workspace, create workspace. Managed virtual networks, data exfiltration protection. So those are the two things that we want to worry about. Managed virtual networks is that option right here. And data exfiltration protection is this option right here. So there are little radio buttons, can be very easy to miss. It's on the networking tab. And I would say these are really important to think about. So a managed virtual network. The idea here is that Microsoft will create a virtual network and they control it for you, hence the term managed. If you want this capability, you must enable it when you create the workspace. If you create your workspace and don't have it enabled, you cannot turn it on later. If you create a workspace with it enabled, you cannot turn it off later. The only route would be create a new workspace. So there is at present no ability to create your own virtual network. So if you have a networking team who really wants to control the virtual networks that your resources are in, Synapse is either generally accessible to the public, or locked into a managed virtual network. There is no third option. So you don't really have that third choice. Maybe someday in the future, but not today. So what does a managed virtual network do? Why might I be considering this to begin with? It does a few things. One, if you have a managed virtual network, Spark pools will be segregated into their own individual subnets. So what this means, cross-pool protection. If, let's say, you're hosting a Spark pool, I'm hosting a Spark pool in the same Synapse workspace, in that case, maybe my Spark pool gets popped. There's some sort of exploit. I install a Python package that's malicious, and it provides access to a bad person who can get into my Spark pool. They cannot move from my Spark pool into your Spark pool if we are running this with a managed virtual network. So there's no way of communicating between the two Spark pools, which is a pretty good thing. It also isolates the Synapse workspace into its own virtual network and opens up just the ports that are needed for the services, for accessing a dedicated SQL pool, a serverless SQL pool, for communicating with the various Synapse services. Which is also positive because, hey, that's going to mean that we're not going to be able to connect to other outside services directly by default. We would have to set things up, we would have to configure it, and it becomes obvious to an administrator. It's not just firewall access, allow everybody from the whole internet to access this thing. This enables the concept of a managed private endpoint. So the rough idea behind a managed private endpoint is that connections between Azure resources do not leave the Azure network. So in other words, I have, for example, Azure SQL database over here. I have my Synapse workspace over here, and I want to connect the two. Maybe I want to bring in some data from Azure SQL database and connect it over here. I can create a managed private endpoint that ensures no network traffic ever leaves Azure's networks. And the main benefit behind that is if there's somebody who has a tap external to Azure and is trying to read information, they're not going to see any of the data because it's only transiting on Microsoft's networks. So it does not go over the public internet. Also means that you can communicate without resources needing public IP addresses. So this thing literally cannot speak to the broader internet. You can also create managed private endpoints to the serverless SQL pool and to any dedicated SQL pools. So that just happens by default, which means, again, all network traffic through your workspace into the dedicated SQL pools or the serverless SQL pool going to happen automatically over Microsoft's network, never hits the public internet. And if you want data exfiltration protection, you must have a managed virtual network. So in order to check that second radio button, you have to check the first. So what is data exfiltration protection? Well, the idea here is this is going to allow outbound data traffic only to approved targets. It sounds a little bit obvious and a little bit benign. There's a lot that this little radio button does. The short version of it, here's my opinion. It works well. It does a really good job of preventing data from getting out of Synapse. But if you are a developer, part of your job is usually to get data out of Synapse, and this strongly limits what you can do. So again, this is something that you must enable at creation time. You cannot turn it on later. You cannot turn it off later. It's either on or off. And that's at workspace creation time. So it severely limits the ability for external resources to reach anything. For the most part, just managed private endpoints. So in other words, that traffic that's only running across the Microsoft network. I say for the most part. There is one major exception, and that is using self-hosted integration runtimes. So if you're familiar with working with integration runtimes, if you have a self-hosted integration runtime, that is basically the only way that you're going to be able to access the broader internet from resources in your Synapse workspace. Synapse pipelines will, again, if you use the self-hosted integration runtime, will work. But pretty much everything else, like if you're in a Spark pool, you can't get out to the broader internet, which, by the way, if you're in a Spark pool, that means you can't run pip, you can't run conda commands to install packages. You're not going to be able to grab packages from the outside world, upgrade packages. You're not going to be able to grab data from external data sources in the outside world. All of that stuff has to be within your Azure solution. So you could have packages that are in Azure Blob Storage that you're able to load. You can have data that's in your data lake that you can access, but you're not going to be able to go to some random website and grab information. Also, will allow you to limit the Azure Active Directory tenants to which you can write data. So this is good in that I can say the only tenant that's allowed to get data from my Synapse workspace is maybe my company's, or perhaps I have my company and then I have a subsidiary company which needs to be able to get some of that information. But we can control, in case J random person has an Azure subscription and they somehow got access to our Synapse solution, they can't exfiltrate data onto their data lake because our Azure AD limitations basically say, no, you can only write to services hosted within our Azure AD world. So a couple of network options that you control. If you have a managed virtual network, you can disable public internet access altogether. That does make life harder for you. If you've not set things up appropriately, you're not getting access back to your Synapse resources. So that is kind of one of those last things that you would do, is disable that. If you want to connect strictly through site-to-site VPNs, or if you have all of your resources in Azure VMs and you're connecting to it from there, you can successfully prevent there from being any public network access. Now, if you don't want to go quite that far, you can use the standard firewall IP address range rules. So in other words, I can say, here's the IP address for my company's public IP, or the VPN that my company employees use, that it all goes out through this IP or these few IP addresses. Perhaps I have a few people who should be allowed to access this. I can manually insert IP addresses or ranges to allow access to these resources, like you would with Azure SQL Database or other data resources. And there's a little checkbox here: allow Azure services and resources to access this workspace. A little tiny thing, and this is probably I'd say the easy button. The easy button basically says anything in Azure is allowed to view to access this data. Now, when it says anything in Azure, literally anything, like J random person's subscription, if I check that box, J random person is going to be able to, if authorization is available, like if I've created an account for J random person, if I've granted them access in IAM, they're going to be able to access this. It doesn't limit you down to just the subscription, to your subscription. So you don't need to check that box. A lot of recommendations will have you check that box because that way you don't have to set up all of the networking. You don't have to go through all the pain of managed private endpoints, but it's also not as secure. I would recommend go through the pain, especially if this is really sensitive data. Embrace the pain. So Ricardo has a question. To connect on-prem data, would a better setup be a managed virtual network with site-to-site VPN or a self-hosted integration runtime? I'd say if your main purpose is, like, if you want to use Synapse pipelines to move data from on-prem into the data lake, you could certainly use that self-hosted integration runtime. If you aren't that concerned about using Synapse pipelines, if you have other processes which move data from on-prem into your data lake, then site-to-site VPN could certainly work. If you want people to connect to the dedicated SQL pool from your corporate office, that's where you'll want to have that site-to-site VPN. So for data movement, either or, I suppose it depends on how you want to do it. For people connecting, yeah, you'll have that VPN. Now let's talk a little about workspace security. So you've created the workspace. You've figured out managed private networking. You've figured out whether you want data exfiltration protection. You created the workspace. Now what do you do? Well, probably going to grant people some access. Most users, you're going to want to grant storage blob data contributor against the storage account that's hosting your data lake. Storage blob data contributor will allow them to read and write to that storage account and is necessary for many actions in your Synapse workspace. So this is a role that I am happy to grant pretty much anybody who should have access to anything in Synapse. The idea here is, look, I'm already aware that you're going to access the data lake. And with data lake permissions, we can limit what exactly you're allowed to see, more fine-grained. But you're just going to need to have access to the data lake to be able to do things in the data lake if you want to work with a managed data warehousing platform built on the data lake. The next step is Synapse RBAC roles. So this is IAM. This is access control for Azure resources. Within the Synapse workspace, there is its own role-based access control system. So these are Synapse roles or workspace level roles. And they are going to control what people can do within Synapse. So this is a real brief rundown. Synapse administrator, basically you get everything. Now, in addition to Synapse administrators, if you're an Azure owner, so if you own the workspace in IAM, you can assign RBAC roles to others. Otherwise, you need to be a Synapse admin to assign roles to other people. If you want to work with any compute, create a dedicated SQL pool, create a Spark pool, stop the dedicated SQL pool, delete a Spark pool, work with the Data Explorer pools, you will need the appropriate Azure permissions, those IAM roles, owner or contributor on the workspace, to be able to start and stop pools. For your Spark administrator, basically that person is going to be able to create and delete and look at Spark pools. They can run Spark notebooks, they can check out jobs, but cannot run Synapse pipelines. Also, none of these other roles are allowed to grant access to others. So this is not, well, Spark admins can grant Spark admin and lower to people. There's none of that. You are Synapse admin, you can grant, or you are not Synapse admin, you cannot grant. SQL admin, you get full access to the serverless SQL pool. You can manage dedicated SQL pools, so create logins, grant access. Basically, think of it as almost DB owner of the SQL pool. You can manage scripts, credentials. You can create linked services, but again, cannot run Synapse pipelines. Artifact publisher is a weird thing. Basically, you can save. You can give a person a role where they can create artifacts, where artifact is fancy term for scripts, notebooks, code, that kind of thing, pipelines. You can actually grant a person the ability to create them, but not to save them, which I guess if you're a really mean person, you could do that. Artifact user is more of, it is read-only access. no management options, but probably you're going to grant artifact publisher to a lot of people because any developer in your dev environment especially, you probably want them to be an artifact publisher. You'd like them to be able to save their work later. Credential users are going to be able to use secrets. I noted that Spark admin, SQL admin cannot run pipelines. Part of the reason you cannot run pipelines is that those two roles do not automatically give you credential user. So credential user going to be required for pipelines because this is how I can read secrets, for example, from Key Vault. Compute operators can run Spark jobs. They can run Spark notebooks. They can view the logs. They can cancel Spark jobs for any user. If you have a compute operator who's kind of a jerk, they can cancel your Spark jobs. It's more of a hiring problem than a security problem, but just something to keep in mind. More often, it could be, I meant to delete my own or cancel my own. I accidentally clicked yours. Sorry about that. They may, if you grant them credential user, run pipelines. So credential user plus compute operator gives you pipelines. Monitoring operator is allowed to read published code, read outputs for notebooks, which means if you have sensitive data that's getting written to notebooks, they can read that. They may view the serverless SQL pool and other pool and integration runtime details, but may not run or cancel any pipelines or Spark jobs. So this is intended more for your maybe frontline NOC type person who you want to have look at some stuff, but you don't want them to accidentally mess anything up. Synapse Contributor is compute operator plus full access to Spark pools and integration runtimes. So plus you can work with published code artifacts, but Synapse Contributor plus credential user needed to run pipelines. So that credential user, that's going to be your limiting factor in who gets to run pipelines. Synapse users are basically, I have granted you the ability to get to the workspace. From there, you will need additional rights to do pretty much anything. You can view details, but you can't run jobs. You can't review code. You can't do much of anything. You could, if you wanted to mess with somebody, I'm not saying you should, but if you wanted to mess with somebody, you can grant them Synapse user, and then they can create a new script against a dedicated SQL pool, maybe to query some data, but they cannot run the script. They cannot save the script. So now that we've talked a little bit about roles, let's talk about data movement. All data by default and by necessity is encrypted using TLS 1.2. So in other words, all data is encrypted in transit. There is no way to turn that off. Nothing you need to do to enable this, nothing you can do to disable this. Doesn't matter if you're using a managed virtual network or not. So this is all going to be covered for encryption in transit. For encryption at rest, there are some options, but basically, again, it comes down to data is encrypted at rest. If you're storing data in your data lake, those disks are encrypted. If you're running a dedicated SQL pool, those disks are encrypted. From there, you can turn on things like transparent data encryption if you want an additional level. So let's talk linked services. Linked services are your way to communicate with the outside world. I'm going to make a connection to an external resource. And one of the things I like about this screenshot is it's not just Azure. It's also, hey, here's AWS. Hey, here's on-premises Impala, or maybe I'm running an Impala cluster. Yeah, I'm running a Hadoop cluster in Google Cloud, and here's the IP addresses for it. So I can connect to on-prem resources. I can connect to other clouds, connect to services or infrastructure. And for Azure services, we can use a managed identity. The managed identity is basically an account that's in Azure Active Directory associated with the Synapse service. And we can grant rights to that managed identity rather than having to create additional accounts and storing credentials and passwords. So the managed identity is a good method of ensuring that your Synapse workspace has appropriate rights, and more importantly, just the appropriate rights. Now, for everything else, you can't use a managed identity. You should store keys and connection strings in Azure Key Vault. You can access Azure Key Vault very easily from your Synapse workspace and be able to pull the keys in from there. There's really no reason that you would ever need to store the keys or store the connection strings in your Azure Workspace detail, in your Synapse Workspace itself, or in any integration runtime. For managed private endpoints, you do need a managed VNet. And this is going to be, again, your most secure way of connecting to other Azure resources. You're ensuring that data never leaves Microsoft's network. But it only works with a limited number of Azure resources. So all of those AWS things, gone. All of those on-prem things, save for self-hosted integration runtime connections, gone. If you can use managed private endpoints, they are going to be the most secure. It's going to allow you to connect without going over the public internet. So if you are mostly a Microsoft shop and you're working basically everything within Azure for your Synapse workspace, that managed VNet's going to be good enough. One quick note is that let's say you're not entirely in Azure, but your Synapse workspace really just reads from your data lake. Well, your data lake doesn't have to be blocked off from the outside world. You could still access that data lake externally. You can still write to your Azure Data Lake storage, write to the right folders from on-premises or from other clouds, and then have Synapse really just work within its own managed private endpoint to whatever services it needs to within Azure, and that's it. And that's a way where maybe you still have some non-Azure resources that need to be able to write data to the data lake, and you're not familiar with self-hosted integration runtimes, or you don't want to use them for whatever reason. There's still some capability in here. You're just not going, you just wouldn't have linked services going to, for example, S3 and pulling data from there. You would instead be pushing data into your data lake. Real brief, pool security. We have 3 pools to talk about. A little bit macabre humor with real brief because this does take a little bit. So let's start with the dedicated SQL pool, because this is going to give you the most opportunity in terms of security space. We talked about Azure level access controls, IAM. We talked about workspace level role-based access controls, your Synapse admin, Spark admin, compute user, credential user. We also have SQL level role-based access controls. And we're familiar with these from any work with SQL Server from Azure SQL Database. These are logins, users, database roles, built-in and custom. So these are roles that you can assign to people to give them appropriate permissions on resources within a dedicated SQL pool. There are 3 permissions that are available: grant, revoke, deny. So if I grant you permission, you may access the resource. If I deny you permission, you may not access the resource. If I revoke a permission, I've canceled out the prior grant or deny. And so we go back to status quo ante. Like, what was it before that last grant or deny statement? Now, this gets a little complicated because you can think of combinations of roles and logins and users, and you control access to whatever objects. So tables, views, stored procedures, functions, whatever you create that are database objects, permissions are going to be inherited, meaning I have a user who is in a database role. I grant access to a table to the database role. That user is going to be able to get all the grants, all the denials from the role. Yeah, revoke does cancel a deny. That's, I mean, in fairness, if you don't have any grants anywhere, it's still effectively a deny, but it's going to cancel an explicit deny. And deny supersedes grant. Here, it doesn't matter how far the denial was in the inheritance chain. So let's say I have a database role, and there's a database role below that, and a database role below that, and then I have my user. If I have a deny up here and a grant down here, deny overrides grant. In some circumstances, there are cases where a lower level grant overrides a deny in some software applications. With dedicated SQL pools in Azure Synapse Analytics, if I have a deny anywhere in this chain, that deny wins out. So let me give you a specific example of that just to make sure it's clear. We have Suzanne. Suzanne is a developer. She is in the developers Azure AD group. Now, developers gets DB data reader on the user database. So developers can read any table in the user database. But then we deny select on dbo.finances. We don't want developers to view finances. Therefore, Suzanne cannot access dbo.finances. Importantly, even if we say, well, Suzanne's the exception, I want to grant Suzanne access, but I don't want those other developers to get access to it. So we grant select to Suzanne. She still cannot access the table because deny anywhere in the chain overrides any grants in the chain, regardless of the level. The only way that we would be able to resolve this would essentially be move Suzanne into a different role, which is developers with financial capabilities. So as long as Suzanne is in that developer's role, she's not getting access to finances unless we grant it to everybody in the role. So next, database roles. Database roles, pretty similar to the ones in SQL Server. And we talked about DB data reader. We also have things like DB data writer. Now in the master database, this is a bit different. Because the master database is weird in Synapse compared to SQL Server on premises, there's not as much that you can do in here. You have a DB manager. They can create and drop databases. You have DB exporter. They can create tables. They can work with schemas. They can work with Polybase, external tables. You have login manager. Well, they can create and drop logins in master. So these three roles don't exist on premises. They don't exist in SQL Server, the box product. They are specific to a cloud solution because you're going to be limited. You're not going to be able to grant sysadmin to somebody as you may be on a shared resource. Dedicated SQL pools. I talked about disk storage, that disk is encrypted. Well, Microsoft always encrypts dedicated SQL pools. They're always encrypted at rest using Microsoft keys. There's nothing you can do to turn that off. However, if your company either does not trust that Microsoft's keys are sufficient or has regulatory requirements mandating that they must encrypt their own data and hold the keys, you may additionally double encrypt your data. So you can use a customer managed key and encrypt the data that has already been encrypted by Microsoft. Based on, encryption works fine if you double encrypt. It's not like the rote 13 encryption method where, oh, I doubled this thing and now we're back to the original. That's not going to be a problem. Performance usually is not going to be a problem. So if you need to, this is an option. And you can encrypt the data. You can ensure that it is that even if Microsoft people were to access this, they would not have the ability to decrypt because they don't have your key. So let's say that you don't need to encrypt it yourself. You could enable transparent data encryption for the dedicated SQL pool. So your auditor says, well, you don't need your own key. That's okay that Microsoft encrypts the data on disk, but we do need transparent data encryption on because it says so in my check sheet. You can enable it, check the box. You'll take that CPU hit. It's a few percentage points, but if the auditor requires it, you can do it. Snapshots and backups written to encrypted disk. So again, you're not going to have a case where you do all this encryption work, but then your backups are in plain plain view, readily available. They have thought this stuff out. Now, within your dedicated SQL pool, you have databases. And within databases, we may want to encrypt certain sensitive fields. Maybe most of the fields are okay, but we have a human identifier, and we want to encrypt that. We can use a concept known as column level or cell level encryption. And the dedicated SQL pool lets you use this: encrypt by key and decrypt by key, a couple of functions. These are also available on premises. Should you use column level encryption, use AES 256 for the symmetric key. I mean, this is technically, you can use 128 and 192 bit length, but don't do that. Just use 256. You cannot use the older methods that are still supported for legacy reasons in SQL Server, like DES, triple DES, RC4. Never use those. Just frankly, don't use it at all. Also, always encrypted, not supported. So if you want to use always encrypted, it is not supported today in dedicated SQL pools. Will it be in the future? I don't know, but not today. So if you want to encrypt specific columns, column level encryption. Column level encryption is pretty simple. You create a master key and a certificate off of that master key, and then you can create a symmetric key using AES 256 encrypted by that certificate. So the certificate's available. You can export it. You could save it. If you need it on a new workspace, you can import the certificate. Then we alter the table and change the data type to bar binary. So I add a new column. Let's say I have a name last column. I'm going to name last encrypted, make that bar binary. And I will open my symmetric key, decrypt it using my certificate, and then I will set dbo.people's name last encrypted to name last using the encrypt by key function off of my personnel key. And I'll turn that to var binary 160. Then if I want to view that data, I will decrypt it by key as in varchar from dbo.people and go on from there. Because we are getting near the end of time, real brief, dynamic data masking is not encryption. Frankly, it's not security. It's technically possible. Row level security will allow you to filter down what rows people are allowed to see based on filter predicates. It will slow things down. There will be a performance impact, but I do have a script that shows you, if you do need it, how you can create it. Data discovery is really important. This is something that you don't get with on-premises SQL Server. I can mark specific columns as sensitive, and there's an automated classification system that will pick things up by default, but I can then modify the results and handle what actually constitutes sensitive data. And then when people query that data, I can get a result of who queried the data when, what query did they write, and therefore get an idea of what they've accessed. That way, if I need to, I can track what you've accessed and can perform an audit later on to see who's viewing what sensitive data. So the serverless SQL pool, very similar, just you're not going to be able to write things, which means that you won't have as many permissions involved. It's kind of boring in that respect, but use role-based access controls. And I've got a little bit more on here about Spark pools and the like, but again, given that we're at time, let's talk about where you can get the slides, links to more information, and that's all at csmore.info/on/lockdown. If you have any questions, please do feel free to reach out to me. Here's my email address. Here's my Twitter handle. And if 45 minutes of this just is not long enough, I do want to point out that I have actually put together a course with the EC Council on securing a data warehouse with Azure Synapse Analytics. And this is 8 hours, more than 8 hours, I think, of material going into depth on each one of these topics and covering it in a lot more detail than we're able to do today. So if you really want to dive in on that, this is a paid training, so it's not free, but that is available. The link here, all of this stuff is free. So go check that out. And with that, Thank you so much, everybody. If there are questions, I'm happy to sit around for a few more minutes, but otherwise, we'll see you back in the main room.